Hi guys. Today we'll be starting chapter 8. Unlike chapter 7, in chapter 8 we're going to go through it just once. We're not splitting it in half or anything like that. But we are not going to go through the entire chapter. So you'll see today we're starting on chapter 8, section 4. We are actually only going to do 3 sections of chapter 8. So we're starting with chapter 8, section 4. Then we'll do 5, and then we'll finish up with 6. In chapter 8, it's going to be essential for you to remember your factoring. So if you still have your factoring book from first semester, you should have that out and handy for the entire chapter, all of chapter 8. And then if you don't have a factoring book, go back and try to find your factoring notes from first semester. And that will also be very handy for all of chapter 8. I put up a couple of factoring reminders on this slide. These are our most common types of factoring, and so these are the ones that I wanted you to really remember. And so the first thing you should check for when you're factoring is you should check and see if there's a GCF, a greatest common factor. If it is a binomial with 2 terms, then the most common type of factoring is a difference of squares. And if it's a trinomial with 3 terms, then you should be doing Xbox. So these are the 3 most common types of factoring. Now, that's not to say that these are the only types. These are just the ones that are going to be used most often. Today, we're going to be taking a fraction that has polynomials in it, and we're going to be simplifying it. Here are some helpful hints to help you in simplifying a polynomial fraction, otherwise known as a rational expression. First of all, if you see any adding or subtracting happening in the problem, you must factor. This is going to be the make or break of this chapter, is if you remember to factor or not. So anytime you see any adding or subtracting, your first instinct needs to be, I should factor this. Next, we're going to simplify by canceling one thing from the top with one thing from the bottom. And so you can't cancel out 2 things on top or 2 things on the bottom. It's got to be 1 on top, 1 on the bottom. And it's 1 for 1. You can't cancel out 2 things with only 1 thing. Since we're going to be doing factoring, we're going to have a lot of parentheses in these problems. Parentheses can only cancel out with another parentheses that's exactly 100% the same. Same numbers, same letters, same symbols in the same order. When you're canceling out a parentheses, you're going to cancel out the entire thing. You're not going to cancel out the pieces, and I'll show you that in some examples. If you have a subtraction problem and it's backwards, so one of them has an x minus 3 and the other one is a 3 minus x, the way to make that cancel is to factor out a negative sign. If you factor out a negative sign, then you can switch the order and then you can cancel. So let me show you what that looks like. So if I have a 3 minus x, I can factor out a negative 1, or you can just put a negative symbol. Then I can rewrite it as an x minus 3. The reason is when I factor out a negative, I'll be doing 3 divided by negative 1, and that'll change the 3 from a positive 3 to a negative 3. And I'll be doing negative x divided by negative 1, and that will change it from a negative x to a positive x. So that's how that works. Now you only have to do that if it's subtracting. If it's an adding problem, just switch the order. Order doesn't matter on adding problems. If you have numbers and variables that are not trapped inside of a parentheses, so these would be numbers and variables that have just multiplication, no adding or subtracting, those you can cancel out the pieces of. And we're actually going to start with that type of problem today. So here is our first example. These are monomials because there's no adding or subtracting. Since there's no adding or subtracting, we don't have to worry about factoring at all. It's just not going to happen. Before we start to simplify, we need to find what are called the restrictions or the excluded values, depending on where you look. The textbook in Delta Math, they might have different words for it. But basically, in math, it's mathematically impossible to divide by 0. And in this problem, we have some variables below our fraction bar, and we're not really sure what those are. So there's a risk right here of us accidentally dividing by 0 and not knowing it. So to prevent that from happening, to make this problem mathematically possible, we need to state that the denominator is not going to equal 0. On a monomial problem like this, where there's no adding or subtracting, all you have to do is say that every variable underneath the fraction bar can't be 0. So I'm going to say s cannot equal 0 and t cannot equal 0. The not equal sign is the equal sign with the slash through it. Those again are called the restrictions, or sometimes they will be called excluded values. It depends on where you're looking. There will be an answer line where you have to write down the restrictions, so make sure that you get into the habit of doing that. And that's one of the first things that you should do is find your restrictions. Once you've found your restrictions, then you can actually simplify your fraction. When simplifying this fraction, I have a 24 and a 32, so I want to simplify that just like I would a normal fraction. So 24 and 32 are both divisible by 8. So 24 divided by 8 is 3, and then 32 divided by 8 is 4. For your variables, there's two different ways that you can approach it. You can use our rules for exponents. We made a secret compartments about it, and our rules for exponents say that we should subtract. Or what I like to do, I like to think of it as also canceling. So for my s's, I have 4 s's on top and 1 s on the bottom. This 1 s will cancel out one of these 4 s's, bringing it down to 3. So as long as you're doing 1 for 1, we're good. So 1 s on the bottom, 1 s on the top. That's going to bring me down to 3 s's on top. For my t's, I have 3 t's on top and 5 on the bottom. So we got to cancel 1 for 1. So 1, 2, 3. So the 3 t's on top will cancel out 3 of the t's on the bottom, leaving me with just 2 t's on the bottom. And so the simplified answer for this question is 3s to the third over 4t squared. Now again, there are two answers. We have our restrictions down here, and then we have our simplified fraction up here. In our second video today, I will be simplifying fractions where there is adding and subtracting, so we will have to do factoring. So I'll see you in a little bit.